Hi, this is Dr. Sanil Rege from psychscene.com. Today I'm going to take you through the interpretation of an odds ratio, and we'll look at the actual interpretation in a actual study looking at chocolate consumption and cardiovascular disease. So first, let's look at what an odds ratio is. An odds ratio is nothing but the ratio of the event or the outcome occurring in the exposed group divided by the event occurring in the non-exposed group. The simple way to remember the formula in a 2x2 table is AD by BC. And that occurs because odds ratios are usually carried out or calculated in a case control study. And in a case control study, as we know, usually occurs when the outcome is quite rare. So if you think of the formula for a relative risk, the formula is A divided by A plus B. But because A is a very small number, i.e. a rare outcome, the denominator A is very minute and can be taken out. Therefore, that A divided by A plus B becomes A divided by B. And similarly, what you get in the non-exposed group, you get C divided by C plus D, but the C in the denominator is tiny, therefore it becomes C by D. So it basically becomes A by B divided by C by D and is equal to AD by BC. So that's the explanation of why it's AD by BC in an odds ratio, but the easiest way to remember it is obviously through the diagonal AD by BC. Now, in rare outcomes, as I mentioned, the relative risk will approximate the odds ratio. So let's look at a practical example. So here, for example, in the 2x2 table, the exposure is prenatal influenza exposure, whilst the outcome is schizophrenia. And as you can see, schizophrenia in this study is a very rare outcome. So that in the denominator, both A and C are very minute numbers. Therefore, even if you calculated A divided by A plus B divided by C divided by C plus D, i.e. the relative risk, the calculation will approximate 1.21, which is the same as the odds ratio AD by BC, because we're dealing with a rare outcome. Now, if I needed to interpret this in terms of an odds ratio, remember that an odds ratio is calculated in a case control study, and we are measuring the exposure. Therefore, the interpretation becomes patients with schizophrenia are 1.21 times more likely to be exposed to influenza prenatally than those without schizophrenia. Note the direction here. It's patients with schizophrenia are more likely to be exposed because we're actually going backwards in time. Now, if this was a cohort study, because a cohort study essentially looks at exposure previously and then the outcome later, and that's why temporality can be established, the interpretation would be slightly different, and we would say patients with prenatal influenza exposure are 1.21 times more likely to develop schizophrenia than those without. So that's the subtle difference between odds ratio and a relative risk. Okay, so now let's look at an actual study and see how odds ratios are interpreted. I won't go through the whole methodology. The methodology of a case control study is well covered in the psych evidence course, but I will go through how to interpret the table and the numbers. So this is a study that's looking at chocolate consumption is inversely associated with prevalent coronary heart disease. So let's go down and go straight to the tables. What they did in the study was really ask people the question, in the past year, how often did you consume chocolate bars or pieces such as Hershey's Plain, M&M's, Snickers, Reese's, 1 ounce, and then they basically got greater than 6 per day, 4 to 6 per day, 2 to 3 per day, 1 per day. And usually this division is done in a case control study because they're looking for a dose response relationship, as you know, which is a key Bradford Hill criteria of causation. So essentially, if there was a strong causation, we would see that as the dose went up, the event was more likely. You will see this in studies such as smoking and lung cancer or any other exposure to an outcome. Okay, so let's go down and look at the actual table. So first I'll look at this table. As you can see here, we can essentially see odds ratios of coronary heart disease according to chocolate consumption in 4 4,970 participants. So the first thing I'd look at is obviously look at the right-hand side, and you can see that there are the odds ratios here, and in brackets you've got the 95% confidence intervals. So very quickly I can see that this is compared to no chocolate intake, which is 0, which is standardized at 1, and at 1.3 per month the crude is protective. So 0.79 basically indicates a protective effect, but it is not statistically significant as this crosses the line of no effect, which was 1. But when we look at Model 1 and Model 2, what do they indicate? Model 1 is adjusted for age, sex, and risk group, which are confounders, whilst Model 2 is variables in Model 1, all these three, plus adjustment for dietary, linoleic acid, education, exercise, and smoking. This is an important step that you will often find in case-control studies because researchers have to adjust for confounders in order to estimate the adjusted odds ratios. So what you can see here, both 1.01 and 1.05 are actually slightly increased risk. So increased risk of 1%, increased risk of 5%, while this was protective and this was basically 21% reduction. Why do I come up with 21%? Because the risk reduction is 1 minus OR, which is 1 minus 0.79, which is 21%. So let's look at 1 to 4 per week. And at 1 to 4 per week, you can see that the crude is protective again, 0.57, and you've got, this is statistically significant. But I'm more interested in the adjusted odds ratios. And you can see the adjusted odds ratio Model 1 is protective and statistically significant because it does not cross the line of no effect. This one is not statistically significant as it crosses the line of no effect. But when we go to 5 per week, what do we see? We see crude is definitely protective and a very high number. So the risk reduction is 100 minus 32, which is 68% risk reduction. And the adjusted one, both of them tend to be statistically significant, and you can clearly see that the risk reduction is again 100 minus 43, which gives you 57% risk reduction for both adjusted. So clearly you can see a dose-response relationship here as the number of chocolate, as the chocolate consumption went up, the risk reduction increased as well, which means that the odds ratio showed a protective effect. Similarly, you can look at the table that basically looks at prevalence odds ratios of coronary heart disease according to chocolate consumption in, again, 4,970 subjects. But here they're divided in less than 60 years and greater than 60 years. And let's see what happens as the dose goes up. The odds ratio clearly shows a dose-response relationship, 0.80 to 0.48 to 0.36. So the risk reduction increases and the protective effect increases, and this is statistically significant as it does not cross the line of no effect. Clearly the p-value also is statistically significant, highly statistically significant. And similarly here, the protective effect continues to increase with an increased risk reduction, which is also statistically significant. So that tells me that chocolate consumption is inversely related to the prevalence odds ratios of coronary heart disease, and therefore chocolate consumption, increased chocolate consumption protects against coronary heart disease would be the simplistic explanation. So I hope you've enjoyed this odds ratio interpretation, and enjoy your chocolate until I see you next time. I'll carry out another interpretation, and we probably will go through the cohort study. Don't forget to visit psychscene.com and the Psych Evidence course if you want to learn more about critical appraisal. Until next time, good luck.